Hi, my name is Stefan Schippers and this is my presentation. I was preparing for the FSiC2022 Conference. I missed due to train problems, transportation issues. So, Xschem is a hierarchical schematic editor. It's specifically targeted for VLSI design, ASIC design, and it can generate netlist for SPICE, Verilog or VHDL, as well as some format for PCB design, but this is not in our interest today. Components can be primitives, behavioral blocks, subcircuits, and it allows to have a true mixed mode circuit description with analog behavioral blocks, transistor level, gate level, whatever is best for your simulation. And this tool has been designed from the ground up to handle very large design as efficiently as possible with no scripting in between for intensive tasks. The core is written in C89, so it's very low requirement in terms of portability, and the GUI is written in TCL/TK, as well as the scripting language used to send commands to or scripting scripts to Xschem. Xschem understands vector instances like this one here, and TCL can be used to do forward or backward annotation, for example, import operating points data into the schematic and so on. It works on most Unix-like operating systems, and also we have now a Windows port, not native Windows available. And as also Xschem is the schematic editor used for the SKYWATER PDK design flow. So next, this is the outline of my presentation. So first I will explain why do we need Xschem, the history of the project, what Xschem is able to do and what is not able to do, the feature list, some comments about hierarchy, symbol creation and component instances, and we'll move forward with explaining instance attributes and parametrized subcircuits, which is especially useful for circuit reuse. Next we talk about simulation, wave viewer, SKYWATER integration, the roadmap, conclusions and contacts. So, why Xschem? I have been a user of Cadence Virtuoso for many years when working for different companies, and the problem with Virtuoso, it's very big software, takes a long time to start up. Creating new components is too complicated. You need also, as a designer, you need to contact your IT support, your CAD support. It uses a lot of system resources, and when everything is exhausted, it will probably crash. There is one single process handling all design windows. If the program crashes, all your open windows are lost. Netlist extraction is too slow because most of the glue logic of the glue is implemented in a scripting language like Skill for Cadence, and very important, the proprietary file format, so it's not easy to import the file in another tool or stuff like that. And another reason for Xschem is that most open source schematic editors today, free open source, are not targeted for VLSI. For example, Xschem or its the fork Lepton schematic and KiCad EE schema cannot handle very large designs. The only one I found which is able to handle VLSI design is XSCHEMATIC, and it has also probably the best graphic quality so far. Next, the history. Xschem is an old school project. It started in 1998 as a hobby when I was working at STM, and then it was first developed on Solaris, Sun, and then on Linux. Later I added Subversion repository and a local Subversion, and then a SourceForce SVN repository in 2016. Development has improved a lot in 2019 to present, adding more graphic objects, automatic configuration, standard location of all install files, documentation, RC files, various improvements, and so on. And also some small companies started using Xschem in 2019, so getting feedback, bug reports, and requests for improvements. I have successfully simulated designs, complete system with ngSpice, XSCHEMATIC, HSpice, Icarus Verilog, ModelSim, GHDL, and I have added a generic interface to simulation engines in 2019, so adding another simulator does not require changing the program. Also, bindings for waveform viewers like GTK Wave, GAW are added, and in 2020 I created a GitHub repository and joined the SKYWATER free and open source silicon initiative, created symbols for the process node, and getting lots of user feedback. What is Xschem and what Xschem is not? Xschem is a free open source. It's a small project. It follows the Unix keep it stupid and simple. Keep it simple and stupid philosophy. So it's very small. It's a digital, analog, and mixed mode circuit schematic editor. It is a hierarchical design tool, so we can create parametric subblocks and wrap the circuit into a symbol and use the symbol multiple times. For example, an inverter with different sizes. It's just one implementation of a symbol and can be used multiple times. Xschem has a syntax for vector notation, both for nets and pins, and as well as instances. For example, this is an instance of 8 inverters, so we can in a very compact way draw complex repetitive circuits. Xschem is very fast, performance must be important, so even a schematic with more than 100k instances is not a problem. Netlist extraction especially must be very fast, and Xschem knows the connectivity of the circuit. The netlist and the logic the logic model of the circuit is embedded into the Xschem core. Next, Verilog, VHDL, Spice, netlist backends are all added, and adding another backend is not very difficult. And also, all the time-consuming computations are done in C, so we are not using scripting languages for heavy tasks. TCL/TK is used for the GUI and as a scripting language, but all the drawing is done directly using the Xlib graphics system. What is it? Xschem is not. Xschem is not huge, has a very limited number of dependencies. Xschem is not using binary formats for storing data. It does not use GTK or Qt libraries, as these libraries are changing too frequently and also changing the APIs. So many projects are bit rotting due to the changing of these API libraries. So I didn't use these graphic library toolkits. Xschem is not a layout tool, although the graphical engine was designed to support layout as well. Xschem is not a circuit simulator, and it's not extremely easy to use. There is a learning curve. You have to learn and see the manual a little bit before starting using efficiently Xschem. Xschem is not a memory hog. A medium design loaded requires 54 megabytes of virtual memory, so it's very small compared to everything I have seen, for example KiCad or Xschem and so on. Xschem is not a C++, C99, C11 project. All code is very portable. It's written in C89, works on all Unix machine, from all the Irix or Solaris up to ARM or current systems. Feature list. The file format for Xschem is ASCII, so we are not using binary format. So, and the format is documented, so you can easily create, even with a text editor, a schematic file, a valid schematic file. We can handle multiple schematic and symbol either by launching more Xschem processes, so each Xschem process handling one circuit, or we have also now tabbed and multi-window interface, so we can have one single Xschem instance handling more than one schematic. We can copy-paste across hierarchy levels. We can copy-paste data on different windows, so you have two windows open, you can select a portion of the circuit and drag the circuit to the next window. Memory footprint is very low. We have, of course, we have undo buffer, so we can undo any operation. Scripting language is TCL/TK, as said before. Net listing can be done in SPICE, Verilog, VHDL, and TE-DEX, which is a format for PCB. And yeah, there are many other functions like snap a wire to a pin, instance pin auto wiring, so we can automatically add nets to a symbol, attaching the labels to the symbol pins automatically. We have no auto router engine, so we are not auto routing wires because it's too complex, and usually the designer wants the circuit to look in a certain way. We don't need auto wiring. And of course we have parametric symbols. We have bus notation for nets and components. It's very portable. Net listing is very fast. Component creation can be done with arbitrary code, so we can easily create behavioral blocks where we design only the symbol with the interface, and then we put some code, VHDL or Verilog code for the block. That's very easy to do. We have we can also netlist in split file mode, where every single circuit is saved into a different file. So every netlist is saved in a different file. This can be useful in some mixed mode contexts. We have also automatic symbol creation for schematic and vice versa. So if you create a schematic with the interface pins, it's very easy to automatically create a symbol for this schematic. Then you can edit the symbol to change the shapes or make it look even better. We can edit attributes on multiple instances. We can change only the modified pair, so we can do block editing on schematics. For example, select multiple transistors and change only the length of the transistors while keeping the width of the transistor the same as before for every single transistor. We can create, we can do pin creation from schematics and so on. Next, let's describe hierarchy. We usually in VLSI design you describe complex circuits by using symbols. A symbol hides the underlying circuit and shows only the interface to the parent schematic. Multiple blocks like resistors, amplifiers, logic gates, whatever, can be used multiple times in a design. So when creating a netlist, the circuit is traversed all the way up, all the way down from the top level to the leaf levels, and all the blocks are netlisted into a file. At the lowest level we have primitive symbols. Primitive symbols do not have a corresponding schematic. We simply tell Xschem how to translate a primitive symbol into a netlist line the simulator understands. Next, we see a typical flow for creating a symbol. So you start Xschem with a new file name. For example, we create an AND here. Second step is do some artwork to draw the shape of the symbol. So you use lines, arcs, circles, whatever you like. Next operation is add the pins. A pin is a red square with some attributes, typically the name of the pin and the direction of the pin. And when you are completing all the pins, you set the global attributes. The global attributes is just text added and locked and text added to the symbol. It tells the type of the symbol and the format, so how this symbol is translated into a netlist, and some default values for attributes. For example, the default name here is X1. You can add some text which will be replaced in the instantiation with the actual name and the actual symbol name of the symbol, and the last task is to draw the corresponding schematic. This is how a symbol is created in Xschem. Moreover, symbols can be parametric, so you can have a symbol and have attributes for the symbol which are passed down to this corresponding schematic. For example, an inverter, you can set up the width of the P, the length of the P channel, and so on, and these attributes are passed all the way down to the schematic. This way you can place multiple inverters with different sizes, and this is how you can reuse your design multiple times. Okay. You can also place a schematic, use a schematic as a symbol. So if you are lazy, you don't need to create a symbol for an inverter like this one. You can also create use the schematic as a symbol. So some designers find this feature useful. I don't like it very much. Anyway, you can instantiate into a parent schematic a schematic, and it will be used the same way as a symbol. Next, simulation. A schematic in Xschem usually contains all the details needed to run a simulation. This includes the circuit, the parameters, and the simulator commands. So when you are done drawing the schematic, you press the netlist button, so you get the netlist, and next you press the simulation button to run the simulator on this netlist. So far we have bindings to many simulators as well as wave viewers. For example, ngSpice, XSCHEM, Icarus Verilog, GHDL for simulators. I have also used in the past proprietary tools like ModelSim, NCSim, and so on, and HSpice, FineSim, and we have also used the viewers like GTK Wave, GAW, WaveView from Synopsys, and so on. Next, Xschem has a very flexible interface to configure the simulators. For example, you see for ngSpice, the line shown on the right tells the command Xschem runs to run the simulator. So there are some variables which are replaced with the name of the circuit. So it's very easy to add more simulators. For example, I have here ngSpice in batch mode, and also XSCHEM in batch mode. And the same for waveform viewers, Verilog, VHDL, and so on. So additional tools can be added in a very easy way. Let's see simulation. I have even simulated very complex systems with Xschem. For example, an 8 kilowatt ROM cell, which is more than 14,000 transistors, and it was simulated very efficiently with ngSpice. So it was surprisingly fast, ngSpice, simulating this huge circuit. So you can see the schematic and the resulting waveforms, either digital and analog. Wave viewing is a new feature of Xschem, where I have added the ability of Xschem to see waveforms, and this is something I want to show you here live. This is a schematic. This is the ROM macro cell, and here you see the graphs loaded directly into schematic. And please consider I am using here digital waveforms, where you can group many bits together and create digital bus. So you have the digital representation stacked of many digital buses, as well as overlaid representation of analog signals here. I think this is a very nice feature, because there are no good waveform viewers around, so I added this feature into Xschem. Next is the SKYWATER PDK integration. You see all the symbols I have created, so MOS transistors, NFET, PFET, resistors, capacitors, diodes, all the primitive devices available in the SKYWATER process are creating, as well as all the standard logic gates available in this process. So the roadmap: I want to contribute to a free silicon ecosystem. I want to add more input filters, improve the native Windows port, and also I want to better integrate Xschem with different simulators without requiring to change the schematic, for example the simulator commands, improve the documentation, and most importantly, feedback from users will drive future development of Xschem. Conclusion: Xschem is a free and open source solution for VLSI design, designed to be efficient, small and fast. Complex mixed mode systems have been simulated successfully. It's a true hierarchic schematic description with parametric components, full support for vectors, bus rippers and vector instances, and ASCII output file format, which is very simple and documented. Thank you for watching.